So hopefully everybody's having fun with the content. I know we had a great time pulling this stuff together, and I'm psyched just because I love doing new content that nobody else has done before. There really isn't enough information out there on threat hunting, so it's been really cool to be able to go through, pull this class together. I think we're going to be offering this eventually as a paid-for class, but any feedback anybody has, absolutely very much appreciated. We want to tweak this. We want to make it as good as we possibly can. So like I said, if you got any questions, comments, I'll toss the address up at the end of this presentation. If you could just drop a line, that would be awesome. Even if it's just to say, hey, yeah, I like what's there, but I'm mostly interested in, is this applicable for this environment? Are you coming out of this feeling like you're getting actionable information? You're getting stuff that you can actually do something with, apply within your own environment. That's really the goal. There's some theory here, but at the end of the day, we want to help fix the problems too. So with that, top of the hour. So hey, let's just jump right in. So what we're going to cover today, just a quick review, literally one slide, that's it, on kind of sum what we've talked about so far. And then the rest of this is tools, tools, tools. Some of these tools we've already looked at. I want to dive into some of them a little bit deeper. Others we have not talked about yet, but there's some cool things you can do with them. So we're going to go through and we're going to run through that today. Starting with that the quick review. So the big thing for me is that threat scoring system. One of the things I see folks get into is they get into this kind of circular process of trying to figure out if something's worth a forensic analysis or not. In other words, they're looking at an IP and it's suspicious, but it's not, and they're not really sure. Assigning some numbers really does make this a whole lot better. It really does make it easier to be able to go through and figure out, is this something I need to worry about, yes or no? So highly recommend you go through and do that. And as we talked about, the primary modifier of that score should be, is there a persistent connection? If you're seeing a system that connects out an external IP once or twice, don't waste your time on it. It's not worth paying attention to. Your major modifier should be, is there a persistent connection there, yes or no? So am I seeing a beacon, a long connection? We've gone through and we've covered that in other modules. So take a look for that first. If that exists, now start looking at some of the minor modifiers. And we went through and we talked about those last week. So things like, is it on a threat intel list? Is the protocol being abused? And it's going to TCP 443, but there's no SSL handshake taking place, that type of thing. Go through your minor modifiers to kind of tweak the score up or down. Because we said, sometimes the minor modifiers might make the difference between not being suspicious anymore. Good example of that is I see something that looks a little suspicious and then I notice it's using an EV cert. Well, an EV cert is a pretty heavy duty check. It costs money. You don't see the bad guys using them. So that's usually a pretty good indicator. Okay, I'm looking at something suspicious. I don't understand it, but it's not necessarily bad. So let's go through and kind of talk through some tools, starting with tcpdump. So tcpdump, so for anybody who's like taken a class from me in the past, I've spent a lot of time teaching how to use tcpdump. With that said, I will say there are some easier tools to use. It's a good tool to know how to operate, mostly because it's always there. Any Linux BSD-based system, you've got tcpdump to work with. On the Windows side, there's a tool called WinDump. It's not installed by default, but you can grab it. You can install it pretty straightforward. But we talked about when we go looking for persistent connections, we want to be able to have a good amount of data to work with, at least 12 hours, preferably 24. You got to record that and you got to store that somehow. tcpdump is just a really nice lightweight tool to be able to go in and get a capture of all of your traffic. And I gave you an example of it here. So, depending upon whether you're on Debian or Red Hat or a variation thereof, depends on which file you put this information in. But if you look at down at the bottom, so we got a pound sign. So this is just a comment that says place above any exit lines. Yeah, if this shows up after exit, It isn't going to do anything for you. What we're doing is we're going to run, we're going to tell the system anytime you reboot, launch tcpdump. So imagine this is hanging off of a span port or a network tap or something like that from my internet link. I want to be able to record all the traffic going by, and I want to be able to write those PCAPs out to a file, and maybe every hour go through and rotate to a brand new file. So I'm just not writing to one file that grows and grows and grows all the time. A little bit of file management here. This also makes it easier for me to go back later and say, okay, I only want to keep these PCAPs for 2 weeks. I need to go in and delete things. Well, you can write a cron job for that once this is done. So that second line, make dir-p op PCAPs. So op PCAPs, replace that with wherever you want to store your PCAP information. Make sure you've got enough disk space allocated for this, because especially if you've got like a gig link or higher, you're going to use up a lot of storage. The -p switch, all that does is that tells makedir, create this directory, but if it already exists, don't give me an error message. So the thought process is the first time this runs, that directory won't exist, so it has to create it. And then after that, unless you accidentally delete the whole thing, it's just gonna, that directory will be there, it won't have to remake it again. Next line after that, so lines 3 and 4 are actually just line 3. So that's one long line that line wraps here. We're using the screen utility to go through and manage a capture session. This is kind of cool because it allows us to connect, to attach to it, detach to it as we need to, so we can go in, and it gives us just some better management capability. The -s capture, -t capture, that just identifies a title and a name for the screen, so that when you're looking at like your PS output, it's pretty easy to figure out what ID has been assigned to this process when it's running. We're using bash, we're running -c is the command we're going to run, we're running tcpdump. Notice -i eth0, I have eth0 in red. The reason for that is you may need to change that to something else. So this command, you should be able to basically copy paste into your own rc.local file, but you might need to change that depending upon how many interfaces are in the device, what the name is, that type of thing. -g is kind of the secret sauce here. That's telling tcpdump, I want you every hour to close off the capture file and create a brand new one. And I want to write it out to ops PCAPs, same place that we used in the makedir. So if you change the makedir to point in a different directory, you obviously have to change that pointer to point someplace else as well. And notice what we did here. We're going through and we're using host name to go in and generate what's the host name of this system, where we're running the capture file. And then we're just going in and using some variables to identify what system was this captured on and what was the date time that this capture was gone through and written. So that way, once I have my, let's say 24 capture files for my first day, how do I know which one's which? It's all right there in the name. And hey, just for good measure, we're going to run it through bzip and compress it so it takes up the least amount of room possible. So big use for tcpdump is we want to work with 24 hours worth of data. This will give us a very easy way to go in and create that. We looked at tshark a little bit already. And if you haven't played around with tshark, hopefully you saw some of the power here. One of the things I really love about tshark is that ability to go in and tell it, show me this exact specific information only. One of the drawbacks with tcpdump is you get a decent amount of output, and you can play around with how much gets displayed using the -t, which is the terse command to minimize it, or -v, -vv, or -vvv to get even more verbose information. But I can't say, show me this field but not that field. It's all kind of pre-programmed. One of the nice things about tshark, which is part of the Wireshark package suite, is I can go in and I can specify exactly what I want to say. So in this case here, I'm telling tshark I want to go in and read this capture file. I want to go in and I want to define the, -T is I want to define the fields I want to look at. So don't show me the default information, only show me the information I specify. And I even get to identify the separator, which comes in, for me, comes in handy. Sometimes it's nice to make that like a space or a tab if you're going to be looking at the output. But if you're going to be parsing it later with tools, commas are so much easier. And sometimes you can't use a comma for whatever reason. You can change it to a semicolon, whatever works for you. But being able to go in and identify what the separator should be just makes that life that much easier. And here we're looking at, source IP, destination IP. This is our protocol. Protocol 17 is UDP. It's going to port 53. And this is the size of each of my sessions. This is the interpacket gap between each of my sessions. So this is my size, this is my timing. So if I want to go in and I want to do a beacon analysis, and we talked about this a little bit earlier, I need to be able to go in and see, okay, all the communication sessions that took place between two IP pairs. I need to see what was the size of each of the sessions. Is there a consistency there? And what is the timing between those communications? Is there a consistency there as well? I may also want to go through and count these up. What I see a lot of folks do is they'll go through and they'll look at how many connections do I have between each of my IPs and each external IP on the internet. And they set some absolutes. So they'll go in and they'll say, if there's less than 20 connections in a day, it's definitely not a beacon. I don't even want to work with that anymore. Okay, that makes sense, because now we're down to less than once per hour. They'll also go in and they'll set a maximum of, let's say, 100,000. And they'll say, if there's more than 100,000 connections, it's not worth doing a beacon analysis. I'm just going to assume this is some sort of a beacon. And if you think about it, it kind of makes sense. If I've got 100,000 connections, I've got more than one connection per second that's taking place. Yeah, okay, I don't need any type of a statistical analysis to figure out these systems are in a persistent communication session with each other. That's probably going to be a beacon. So below a specific threshold, we say definitely not a beacon. Above a certain threshold, we say definitely is a beacon. And then we just analyze the stuff that's in the middle. So again, tshark's ability to go through and extract out just what we need only makes that process a whole lot easier. But you can also do some other cool things with tshark. So we talked about some of our minor modifiers, things like, is the user agent unique within your environment? How do you find that? Well, I'm telling tshark, read in my capture file, -t fields, so I want to specify the fields. And the only field I'm specifying here is the HTTP user agent field, and that's it. And I'm saying only show me TCP, show me the traffic, or only apply this to the traffic. So this is actually a filter with a TCP destination port is equal to 80. So this will only impact traffic going to TCP 80. If it's HTTP going to some other port, I'll miss that doing this analysis. But at least I'm not trying to see if there's a user agent on every port this way. That'll just make everything take way too long. And then I'm going in and I'm saying sort it, show me unique instances and count it. And then I want to do another sort numerically in reverse in numerical order. So so my first sort just goes through and collects all of my user agents that are similar next to each other. Unique -c is going in and saying, show me only one line, count how many instances of that shows up. And then the sort -n just says the most unique, put that at the top of the list. And as you get less unique, bring that down to the bottom. And now I just said head 10. Show me the first 10 entries that take place, and that's it. So again, this is a very quick, easy way to go through and find this. Now I'm reading this in as a sample file. I could tell tshark monitor traffic on the network and flag this stuff anytime that you see it. So I'm working with samples because I'm assuming we've collected 24 hours worth of data and now we're going in and doing a threat hunt. But if I've got the resources to, let's say, run multiple instances of tshark, I could actually go in and just do this live and have this pop up. You're not going to get the neat little sorting like we have here because, again, it's going to add stuff as it goes. But if you want to see what user agents are being used in real time, this is an easy way to be able to go through and do that as well. Now, we looked at an example of this a little bit earlier, but I wanted to pull it back out again. So here what I'm doing with tshark is I'm going through and I'm identifying how many fully qualified domain names are associated with each domain. Remember we said that if you see a high number of fully qualified domain names, and the magic number I use is 1,000. Anytime I see more than 1,000 hosts associated with a specific domain, that puts me into investigation mode to see if DNS is being used as a C2 channel. So that's what we're doing here. tshark is going in, it's reading in the capture file, specifying fields, and I'm going in, the only thing I'm specifying is -e, show me the DNS query name field. That's it. So any DNS packets that don't have that field, it's not going to bother showing me anything. and I'm saying only show me UDP destination port 53 traffic. Now, if I wanted to be complete, I could go in and say, or TCP destination port equals 53. That way, if it switched over to TCP, I'll catch it that way as well. We're sorting it, we're running it through unique. I talked this one through before. The reverse order was the weird one. If you go back to last week's content, I walk you through why I'm doing what. But the idea is, let's only look at the top level domain, akamyedge.net, akadns.net, amazonaws.com. Only grab those fields, and then I'm going to sort them and count them, and then I'm going to display them in reverse numerical order this time, because the higher number of hits, those are interesting to me. With the user agent, small number of hits, those are interesting. Here, high number of hits are interesting. And you can see this top one just stands right out. 62,000 fully qualified domain names associated with this domain, r-1x.com, that I've never heard of before. Okay, that now looks pretty suspicious. We said the magic number is like, 5 to 800 in that range there for the really well-known companies that are offering internet-based services. Akamai Edge, everybody knows who Akamai is. I see 154. Everything else after that is less. The other rest of these look okay. But that first one, I now need to go in and do some sort of investigation. So again, this ability to be able to go in and just identify the field I want to say, really powerful. If what can I display? What can I print out like this? Do a Google search on Wireshark display filters. And the Wireshark display filters will show you this format, and it'll show you, what fields you can grab. That's what you want to be going in and using here. Because again, tshark is part of Wireshark, so they're just using the same syntax. And Wireshark. So this is a tool most people know. Most people have used a lot. And I have to say, this is an incredibly useful tool. Packet analysis with guardrails. What do I mean by that? What I mean by that is Wireshark has a lot of decoding capability built right into it. In other words, you don't have to really understand DNS and the fields and the offsets to each of the values. It'll just go through and do all that for you. You don't have to remember which bits in byte 13 of the TCP header stand for which flags. It understands that. It'll go through and just print that out for you. So especially when you first started getting into packet decoding, Wireshark's great. The only real negative with Wireshark is it's very manual. This tshark stuff that we're talking about here, this can be automated. I can go through and I can easily hack together a bash script to run this every day for me and print this out as a report. So I'm not doing this. All I'm doing is reviewing this. And if I'm really good at this, I could actually write a bash script that I don't have to look at that unless I'm seeing something where the line entry matches a value of 1,000 or more. So again, I can automate this as much as possible, which is really cool. Wireshark, graphical tool, really hard to automate. So it's a little bit harder to only get involved when necessary. You need to be kind of hands-on when you're using this tool. Excuse me. But it is great for getting summary information. Now, I've played around with tshark, cap info, some of the other tools that come with Wireshark. And there may be a way to extract this out of the command line. I haven't been able to figure it out yet. In other words, these stats that you can get out of Wireshark, there's probably a way to do that at the command line. I have not seen it. If anybody has done that and has a command example and you want to throw it in the chat session, I would really appreciate it because I've spent a good amount of time poking around. I've only been able to find it here. But we talked about long connections where something goes in and opens up a connection with an external IP and just leaves that connection open all the time. That's suspicious. That could be C2. It could be normal, but it could be C2. That's something we're going to want to go in and investigate. How do I easily go through and see which connections are being held open the longest? Well, go into Wireshark, load up the file, go to statistics, go to conversations, go to TCP, go to UDP, look at the duration times. That's going to go in and that's going to tell you, where are my longest connections? Where are the ones I have to pay the most attention to? Notice these first couple of values here is almost the entire 24-hour period of time that conversation was taking place. So that's something that's certainly worth paying attention to, especially if I don't recognize these destination IP addresses that they're going to. If that's not a business partner, if that's not a vendor, if that's not a field office, if it's not something I recognize, yeah, I got to do some digging here to figure out what's going on. Bro Zeek, I've talked about this one. So it used to be named Bro, it's now called Zeek, but I've found a lot of folks haven't recognized the name change yet. The binary is still named Bro, so they haven't fully converted things yet, but they have changed the domain name. But this is a great tool for going in and doing a lot of this analysis. And what's kind of nice about it is you can do the analysis on PCAPs, or you can actually do it in real time. So you can just tell Zeek, monitor the wire, here's the types of things I'm interested in. It'll write that out to log files for you. You can go in, you can parse those log files and extract out whatever type of information that you're looking for. Things like long connections, beacons, it gives you all the timing data you need to be able to go in and start figuring out a lot of that stuff. And BroCut, oh my God, BroCut is your friend. So BroCut is kind of like the -T fields that we were talking about with Wireshark, where it allows me to go in and just see the stuff I want. If you're running Zeek and you haven't looked at the log file, you need to. But they're not easy to read. There's a lot of information that they encode in there. So it's a whole lot easier is to go into a file like the conlog file. Right at the very beginning, it identifies what all of the columns are and what they're being used for. So like id.orig.h is the source IP address. So it'll identify that column. If there's stuff I want to see in one of these log files, like the conlog, but I don't want to have to actually look at everything, I can just dump it through BroCut in order to be able to grab that information that way. So here, I've just specified the specific fields I'm looking for. And the big one I'm kind of interested in here is the service field. What did you identify at the application layer? Now, Zeek does this really cool thing that is a distinguisher versus a lot of the tools out there. A lot of tools, if the traffic's going to TCP/80, it will label it as HTTP. Well, no, that's the well-known port for HTTP, but all traffic that traverses TCP/80 is not automatically HTTP. It could be SSH, it could be anything. So you don't know. One of the cool things they do with Zeek is they've got about 50 or 60 application decoders that are built in by default, and you can add in more yourself. And what they do is they go in and they do a protocol analysis. So it will, so let's say we saw traffic on port 1234. It'll go in and look at it and say, hey, does this have headers that are an indication that this might be HTTP traffic? No? Okay. Is it SSH? No? Okay. Is it NTP? No? Okay. And it'll actually go through all 60 decoders until it finds one that it gets matched to, and it'll do that on every single port. So it's great for finding applications running on non-standard ports. Like my web server is listening on port 8080 instead of 80, Bro will still find it. It'll still identify it as such. For the purposes of threat hunting, though, what we're interested in is traffic going to a well-known port like 22, that should be SSH, but we don't see the application header identified properly here. So here this is saying the traffic was going to 22, but we don't actually see the SSH header take place. The server should identify it's an SSH server and what version it's running. And then after that, everything pretty much gets encrypted, but there should at least be that. And if I'm not seeing that, something else is taking place here. So anytime I don't see the protocol on the well-known port, that could be an indication of tunneling. It's a very popular technique for C2. Again, attacker compromises an internal system. They need to communicate out to the internet. Your network's a black box. They need to pick a port you're most likely to let out. 80, 443, DNS ports, UDP, TCP, 53 are common ones for them to go after. So anytime I see this on a port I recognize, that's something that's definitely worth paying attention to. I can also do some other really cool things like, hey, what do the digital certificates look like that all of my users are connecting to? Both inbound and outbound, you can actually do this check. So Bro creates a bunch of log files called, they start with SSL. So it'll be like SSL.00 will be the first log entry, and then there'll be a date stamp. So that's the first log entry for that day, and it'll show you the times that it went through and ran. So for any given day, I'm going to end up with 24 SSL.something files that have been created. So here I'm saying, okay, cat, just display the contents of all these files, run it through BroCut, show me the source IP, the destination IP, show me the destination port, and show me the validation of the digital certificate if one was used. So if I see a dash here, that tells me no digital certificate went by on this port. Well, if I'm looking at TCP 443, why not? I should have seen a certificate go by. If I don't see anything, that's something to be concerned about. Here, I was very specific in what I wanted to look for. I want to see all instances of where self-signed certificates are being used. So I just went in and I said, okay, show me the validation status. And now I want to search to see, is self-signed in the character string? And if it is, it's identifying all of my self-signed certs. So here's a non-standard port, 9943. I think that's VTalk or something like that, but it's not a standard port you see get passed around. But I've got users on the internet talking to my internal server that's using a self-signed cert. Okay, if it's a hack or I'm doing testing or something, self-signed cert is fine. But there's no way to validate that. There's no root authority I can trace through to validate whether that digital certificate's okay. So I'm kind of hoping it's okay. That might be all right here, that might not. We kind of need to look at the application. Again, if I'm just in doing some testing, sure, self-signed cert's great. Don't worry about it. If I'm actually having people on the internet connect to my internal server and I want to make sure their connection remains secure, I can't use a self-signed cert. It's got to be a certificate authority where that certificate can be checked. But Bro will actually go through and check the authority to see, is this a valid certificate or not? Yes or no?
Hey, Chris.
So again, yes.
Chris, we got a question. For BroCut protocol headers, when you're analyzing port traffic, what is the reliability of the flag information? Is it likely that these are doctored or changed?
Meaning that someone may have mucked with it in the packets that they were sending. Yeah, I would always assume somebody may have mucked with something. As far as like Bro getting it wrong, I mean, anything's possible, but I have not personally run into that problem. So if I go in and I say, show me this information, BroCut's really good at showing me that specific piece of information. Now, all it's showing me is this is what was in that packet stream. Was what was in the packet stream manipulated by one end or the other? Yeah, that's always a possibility. But, for something like this is actually a process that Zeek's going in and running. So Zeek is going through and grabbing that digital certificate the same as the client would. The difference is that most clients are set up to just kind of look at, is it a certificate authority that I already know about? If so, let me do a check with the public key I have stored locally. And if it looks like it's okay, bang, I'm done. You can actually tell Bro, no, go down the rabbit hole. So validate that first digital certificate, but then validate the digital certificate being used to validate the second, the first digital certificate, and now go down the rabbit hole and do all your verifications from there. That, if an attacker messes with it, the only thing they really could do is maybe steal a cert and, run bogus DNS information. And if they pull all that stuff off, yeah, it's possible. You might look at something here that looks like it's legitimate cert and everything's okay, but it's going to fool everything else too. Bro's pretty good at what it does. Make sense?
Yep, answered, and he said thanks.
Awesome. So the R tools kit. I wanted to toss this one in. So this isn't really a threat hunting tool, but especially when we're doing a beacon analysis, a lot of it comes down to statistics. We're looking at things like, let me take all of the sessions that took place over the previous 24 hours. And now let me look at the minimum session size that took place. So maybe, the smallest size is 50 bytes. And now let me look at the largest size. Okay, the largest size is 10,000 bytes. Now, what's my mean? In other words, where does a majority of those lie? If it's close to that 50 byte mark, that's usually an indication of a heartbeat. That's usually an if it's exactly in the middle, well, I've got a mix of session sizes and it's probably not going to be a beacon. But if it's fairly close to what my minimum is, yeah, that could be a beacon. This is something worth paying attention to. So what this is for is when I've gone through and I've extracted out, the example I gave you here is with tshark. You can do this with Bro as well. But we were going in and we were grabbing how much data was passed in each session, and then we were also grabbing the timing gap between each session. One of the quick, easy ways to kind of figure out is it a beacon or not is to go in and do a statistical analysis. Now, the weakness here is that if somebody's gone in and used something like jitter, doing a time-based analysis probably isn't going to go too well. That's what jitter's for, is to make that harder. But you can go in and you can kind of normalize things out over a longer period of time in order to figure that out. There's some steps to that. I can go through that. I'll go through that a little bit later. But the R toolkit is a great toolkit for doing your statistical analysis. One of the problems we run into, and it's kind of funny because unless you're like into the whole scientific thing, this is something you'd probably never even think about, is that if I go in and I say, if I go in and I have a hypothesis about how something works, and then I have data that backs up my hypothesis, and I show numbers to show that, hey, this is why I think this works, and then you go in and you try and repeat my experiment, your experiment may go exactly like mine, but if you're using a different statistical software package than me, your final numbers may end up actually looking different, which means it looks like you did not repeat my results. And for the longest time, we used proprietary software, and they did, sometimes the math is different, and that was causing problems. So where R came from, this is a great example of, just open source kicking butt. Because it's open source and anybody can use it. Now, if I go through and do an experiment and run statistics, and you repeat my experiment, R is available to anybody. You run it through R. If you get the same numbers, we know everything went exactly the same way. So it's a nice, it's worth kind of reading about the project and where it's been applied. It's also got some graphing capability built into it, which I don't cover here. That might be kind of interesting for some folks too, as far as pulling some of this information out. And RITA, I want to talk about this one a little bit. So RITA is our open source tool. RITA takes Bro as its primary data feed. So we've looked at Bro and we've looked at, how we can try and identify beacons and long connections and that type of thing. But we've got to go in and we've got to use BroCut, and we've got to kind of sort out the information we want to. One of the nice things about RITA is RITA does all that for you. In other words, you don't need to go in and cut things and run statistical analyses to figure out if, two sessions are a beacon or not. RITA just does that automatically, and it will tell you, yeah, here's how certain I am you're actually looking at a beacon in this particular case here. So it's a great way to go through and save time. It's easier to use than Bro by itself. It's not as easy to use as our commercial product. But and most of that's just because it's text-based output. So, but if you don't mind writing some scripts to kind of automate things, on the command line around this, and you've got less than, let's say, a gigabit connection to the internet, this might actually work out to be a pretty good tool for you. Because if RITA just out of the box does some really cool stuff, like beacon analysis, like long connection analysis. So this very first column here, this is on a scale of 0 to 1 or 1.0. How certain are we it's a beacon? The closer you get to 1, the more certain we are. You can see these, these first couple are almost perfect scores. And then we get down here and now we're down to, we're 92% certain. So if I'm worried about, are there beacons on my network, I can just have Bro feed its data into RITA, have RITA go through and do that analysis for me. And now I can say, all right, if it's, if RITA is 95% certain, or, if it's 0.95 or greater, that it's a beacon, yeah, that's something I want to go in and investigate. And, we've got a bunch of things we go in and identify, what we're looking at. But one of the big ones to look at is count. Count is just how many packets did we say? Here's 108,000 packets that was exchanged from this internal IP to that external IP. Remember we said you get to a point where there's just so many sessions that took place in 24 hours, it's not worth doing a beacon analysis. Once you break that one connection per second mark, it's not worth doing a beacon analysis. It is a beacon. They're in constant persistent communication with each other. That's a great example of that. And then if I go down to the next one after that, we're down to 5,902. Okay, that's still pretty high. That's something I want to seriously take a look at. And then as you get down a little bit lower, the numbers get smaller. Down here, we're down to 164 connections. Yeah, okay. Not very likely this is a persistent connection between these two systems. So again, RITA will go through to the beacon analysis. It'll also do that. Hey, how many fully qualified domain names are associated with a specific domain? It does all that for you. So here this is telling us r-1x.com, there were 63,000 unique fully qualified domain names that were part of this domain. And there was 109,000 lookups done within that r-1x.com domain itself. So, everything was looked up on average twice is really what that kind of plays out to be. So again, is DNS being used as a covert communication channel or not? Yes or no. So long as Bro can see those communications going back and forth, so long as it can see the DNS query going out, the answer coming back, it can go through and produce this for you. That keeps you from having to do all the bro cut stuff that we talked about and the sort and the unique and all of that. Just bang, use RITA and you're done. And it'll also even output, if you want to see what were those fully qualified domain names. So let's say I go in and I see this and I say, okay, I'm certain this is bad. Let's say I look at this and I say 237. Yeah, I'm not sure. I want to see the hosts that are being looked up. This is, if you look at this, look at all the 2020s. That's an ASCII conversion thing. It's pretty obvious just looking at these names, a person did not create those, right? But it's kind of hard to write a BP filter to be able to go in and make sure you catch this type of thing all the time. In other words, I look at this and I would say, oh, well, hey, look at all these instances of 2020, 2020 within that fully qualified domain name. I'm going to go in and match on that. Well, gee, how's an attacker get around that, right? Don't use that in the name anymore. And all of a sudden my BP filter doesn't work and I'm not going to see this stuff anymore. So, it's easy to go in and kind of change these names. So that kind of fuzzy matching, the ability to be able to kind of look at it and say, oh yeah, that's definitely suspicious. It's a lot easier for humans than it is to go in and kind of write a script around it. But if I go in and I see something that I look at, I say, yeah, I'm kind of suspicious about that. You can pull up the details on what RITA is seeing to kind of verify for yourself. Yeah, okay, this is definitely DNS being used as a covert communication channel. This is something I need to go in and pay attention to. Now, I promised that this class would not be a heavy sell, and it's not. I've only got like 3 slides in here on AA Hunter, which is our commercial product. But this is the market space we're going after. So to try and simplify this as much as possible, that's what AA Hunter is for. And the big difference between it and RITA, RITA is our open source tool. Anybody can download it, anybody can use it. That's awesome. The big difference between it is we've specifically designed AA Hunter to be used in a security operations center. So it's designed to be simple, automated as much as possible, and a tool that like a junior analyst could use. And with that, we do some cool things with it, like this is what the alerting looks like in AA Hunter. So one of the problems you always kind of end up with alerting is that you either get, it's always like one extreme or another, right? It's either that one log file that went by that wasn't interesting enough to pay attention to, and that was the thing you should have noticed, but it isn't documented anywhere, so you had no idea, so you missed it. Or something goes off so often that you just like start ignoring it because it's going off all the time. We wanted to do the alerting a little bit differently. So what AA Hunter does is a constant rolling 24-hour analysis of all of your internal systems to see, do any of them look compromised? So if you think about it this way, so I've got an internal system, it's in a safe state, it has not been compromised, and then all of a sudden, phishing email comes in, user clicks something they shouldn't have, and bang, the box gets whacked. What happens next? Because remember, normally it's going to take us about 6 months to figure out that happened. How does AA Hunter kind of deal with that? Well, notice my first alert here, it says that this IP address has exceeded the predefined threshold of 90. So we've just said, hey, anything with a threat score over 90, I want to know about it. and it's saying it's 94. Well, this doesn't help too much, right? Because if my original threat score was 10, yeah, I'm worried about this. If my original threat score was 89.999999, a couple points higher, that's not a big deal. I'm not worried about that. But notice what happens 2 hours later. So remember, this thing's compromised. And once it gets compromised, as time goes on, we have more and more data to look at to be able to say, yeah, this is something you're going to be worried about. Notice what happens. Score goes from 94 to 104. 2 hours later, 104 to 129, 129 to 144. Here we are 8 hours later. We've gone through from some score below 90 to a score above 194. So from like a security operations standpoint, what do I tell my junior analyst to do? I tell my junior analyst to say, hey, if you see 3 or more alerts go off in a 6-hour period of time where the score is constantly increasing, and it's increasing by a magnitude of like 20% or more, involve somebody senior. Get a senior analyst involved because that box has been compromised. So again, we've tried to kind of work the alerting so that it's really easy to figure out, has my box gotten whacked, yes or no? And we try to summarize things. So we talked about like major modifiers, minor modifiers for that threat score. All that type of stuff is just built right into the product. So we go in and we look to see, is there a persistent connection? If there is, large number of points for that. And then we look at the minors, things like unexpected protocol, small amount of points on that when it's seen, bad digital certificate, small amount of points for that as well. But it's all right here in the dashboard. So my left-hand side, this is my most likely to be compromised system at the very top. Scroll all the way to the bottom, that would be my least likely to be compromised. And here's why we think it may or may not have been compromised, based on our first pass threat hunt review. So the tool's really going in and doing a lot of this stuff for you. Passer, we talked about this one. So this is another one of our open source tools. And this is really cool for collecting internal information. One of the things that that's kind of a bummer is that it's actually easier to learn about an external IP than it can be about an internal IP. In other words, yeah, I've been in many environments where you say, hey, this IP address out on the internet, I'm not too sure about that. And you can talk to like an IT person and they know a half a dozen websites they can hit to see, okay, is it on any blacklist? Where is it located? Is it coming out of China? Is it coming from a business partner? Researching external IP is pretty quick, easy to do. Internal IPs, okay, now it comes down to how much prep work you've done and how things are laid out. I've been in environments where, where I've said, hey, 192.168.1.10, I think is acting suspiciously. What is that system? And I go back to the IT folks and say, tell me what the system is. And it takes them a couple hours to come back to me because they have no way to inventory that IP. They need to go back to the DHCP logs, which MAC address was assigned that. Okay, now that they got the MAC address, who made that network card, and what else does that thing talk to? And yeah, okay, I think it's a desktop based on this information. Oh my God, it's hard. Passer's designed to fix a lot of that. So with Passer, you can go in and you can identify, what is the system? Is it an Apple TV device? Is it a Windows box? What is it? What ports is it talking to? What ports does it appear to have open? So this is a great little resource for, hey, 192.168.1.10 is acting suspiciously. I just go into the Passer log, search for that IP address, extract out all the information associated with it. And now I know I've got a fingerprint on the box. I can possibly see what operating system it's using. I see what ports it's been trying to talk to, what ports has been talked to on it. I get all that information to work with to be able to figure out what's going on with that internal system. So it's a great little tool. Now, this isn't so much a tool as maybe a resource, but I couldn't really figure out where was the best place to kind of toss this in, so I decided to toss it in here. So the thought process here is communications that are going to a well-known domain are probably not a threat. And I'd say that's true 98% of the time. In other words, I've run into situations where we've seen what looks like C2 communications, and it's going to Fastly. Fastly does CDN services for a lot of companies. They get a bunch of other related services that they offer as well. But they're a fairly popular site, a lot of customers, tends to be fairly busy. but that doesn't mean somebody couldn't use them for domain name fronting on their C2 server. In fact, it's been seen in the wild. So the thought process that the top million domains are probably safe, be careful with that line of thought. It is kind of good for just kind of a sanity check. How busy is this network normally? If I see I've got a lot of internal systems talking to a domain that I don't recognize, and then I see that that domain, hey, so all my users keep talking to this Twitter thing, and I've never heard of twitter.com. What the heck's going on here? If I go to the Majestic list and I see, oh, that's site number 12 out of the top million busiest sites, okay, now it should be no surprise to me I'm seeing a lot of users talking to that address. So it is a great resource for kind of running stuff down like that. Open source threat feeds. So the other thing I may want to do is I may want to look to see, okay, this IP address that my internal system is talking to, has anybody noticed it, bad stuff taking place with that IP? In other words, did Mary over at this other .com company figure out that one of her boxes got whacked and it's using that IP address as its command and control server? If Mary verified that, well, now I don't have to bother verifying it. I can just pull it out of the threat intel list, and now I know I need to worry about it too. Yeah, that helps. I don't put as much faith in this as I see a lot of people doing. I see people like, plugging this into their firewall rules. Oh, if it's on this list, we'll ban it. Be careful with that. Couple of qualifiers you want to look at. Things like, how old is the entry? A lot of this comes down to the quality of the list. If you're looking at a IP address that ended up on the list, I'm going to say more than 7 days ago, it doesn't matter. Excuse me. Attackers are changing the domains they use. They're changing the IP addresses they use constantly, sometimes dozens of times a day. So if you're working off of information from a week ago or 2 weeks ago, it's probably pretty damn useless at this point. So how old is the entry? That's something you want to pay attention to. Why was it flagged? So if I'm worried about detecting C2 type of communications, and this thing was flagged because it scanned somebody's website and they're not sure why it was doing it and what was going on, and no, those aren't really related. So yeah, if I'm assigning a minor amount of threat points based on whether it ends up on an intel list, some portion of that should be applicability. If somebody was again sending spam or scanning people's websites, and that's why it ended up there, that should be worth like half of what you would normally assign for something that's on a threat intel list, because it's not applicable. So again, be careful with these. And also you'll notice a lot of these come back to a dynamic IP address space. So, and I think I mentioned this last week, or the week before, one of those two classes, Amazon EC2. If I shut off my instance, if I don't just reboot, if I shut it off and then immediately turn it back on again, it gets a different IP address. So now if I go in and I do if I run a C2 server off Amazon and I run it for like an hour or two and then shut it off and then bring it back up again, and now it's got a different IP, I could probably still point the same fully qualified domain name at it, have all of my bot army still work the way it's supposed to. But now the old IP address that's now been allocated to somebody else, that's the one with the bad reputation. So again, be careful with this one. But there's a lot of decent threat feeds out there that you can use. I gave you a list of them here. The known C2 servers is kind of a good list to go in and kind of reference. It doesn't hurt, meaning, if it's on a threat tell list, don't just assume, but it doesn't hurt to know that and to start doing some investigation work as to why it ended up there. And some things to look for, things like, is the address space dynamic? So here's an example threat intel list. Most of these IP addresses here are dynamic. They're either part of a public cloud, or they are part of a web hosting environment where one specific domain was found to have that got compromised or had malware on it or something went wrong. But there may be 50 or 100 other web servers at that same IP address that were all clean and kept up to date and they were fine. So that's, so the address space might be dynamic. The other thing to look out for is the date timestamps that you're given as part of the records. Notice these are all exactly the same second. Okay, that tells me that that's a timestamp for when this was extracted out of a database. It's not a timestamp for when this entry was first created, and that's actually the timestamp I'm most interested in. Because if this entry got created an hour ago, yeah, that's valuable intel to me. This is very useful information. If it was created 6 months ago, but pulled out of the database, a couple of minutes ago, well, out of the database doesn't matter. It's 6 months old, it's gone. Somebody else is definitely using that IP address by now. So, a couple of things to kind of look for when you're figuring out which threat intel list to go with. And that's it for today. So we've got, we've gone through a bunch of tools. There are more. There's more out there. If you do some Google searching on, threat hunting tools or threat hunting just in general, or threat hunting GitHub is going to pull you up a couple things as well. There are some other tools out there. There's a couple I didn't talk about only because I've kind of played around with them and just haven't been overly impressed. That they aren't tools that I kind of feel like I want my name on recommending that people go in and use them. And for a lot of them, it's this: they work great in a lab, they don't scale. Meaning that if I have a sample data set and I know what's wrong in that sample data set and I run it through its tool, it kind of feels like it works. If I've got a 1 gig connection to the internet and I'm jumping random traffic through it all the time, and some of it might be evil and some not, number one, the tool might not scale to a gig. It may not be able to keep up with that much traffic flow. Number two, it may not all of a sudden be so accurate finding the bad stuff when it's an unknown data set. So there's some tools like that that I just haven't bothered to kind of pull in on this. But next week, we're going to start kind of pulling together the tools, the processes we learned. We're going to talk about actually creating a threat hunting runbook. So the idea is we've got a security operations center. What processes do we want to put in place? How all of this should kind of work? So threat hunting, we know, means find the bad guys if they're on my network. But how do I do that? What are the exact steps? I've kind of jumped around a lot. I'm going to pull that together next week. If anybody has any questions they want to toss out right now would be the time to do it. And I mentioned at the back at the very beginning, if you could send me some feedback. Courses at activecountermeasures.com. I like the class. I don't like the class. It's interesting, but I can't use it. Whatever feedback you have on the content you've gone through so far would be greatly appreciated. And with that, Jason, I'm going to toss it to you to see, do we have any questions in the queue?
Sure, Chris. One of the first questions is, let's say you install one of these new tools and you want to see what bad looks like. Is there some kind of way to test it just so that if you're using the tool for the very first time, you know what bad looks like, so that way you know what good looks like?
Yeah, good question. So so the easiest way to solve that is to go in and grab something like DNSCAT or GCAT or some C2 tool that the bad people will use, generate some data with it, and now go in and run it against that to see is it detecting it or not. Metinterpreters, another good one for that type of thing. So go in, create the bad traffic yourself. As far as are there archives out there of known to be bad traffic? Not that I've seen, but I tell you what I'm going to do. So drop me an email at courses@activecountermeasures.com. Let me know what you've thought of the class so far, and let me know you're interested in a data set that has some bad traffic in it that you can go in and look for the bad traffic and kind of compare that to other stuff to see if your processes are working or not. And I will happily share that information with you. We're actually going to do something similar to that at the end of this. So next week, I'm going to talk about threat hunting as a run book, but I'm also going to make a data set available for folks to go through and do a threat hunt on. So it has bad stuff in it. You need to go in and try and figure out what is the bad stuff. I'm going to leave it kind of open as to what tools you want to go through and use. Leverage that as part of the vetting process. If you want more than one data set, like I said, drop me an email. I will send you some other stuff that has some interesting stuff in it, especially like the Metinterpreter. That's a fun one. And that one's kind of tough to catch because that's like, it's a beacon. It's kind of a mixture of beacon and long connection. They're beaconing, but every half hour. So it's there's only like 50 connections in a day, but the connections are only lasting 30 minutes, so it doesn't normally, hit to the top of the list. That's a fun one to kind of play with. I'll share that one out if folks want to see it.
Cool. Next question. If you're a medium-sized business, maybe 1 or 2 people in working in security, and you have not started threat hunting, what would be the first tool out of the list that you went through today to get started?
So the first thing I would want to do is start setting up a data collection baseline. And quite honestly, the first tool I would go with, if it was me, is Zeek. Zeek is great because it's not doing full packet captures like we talked about with tcpdump, but it's also not using up as much storage as a full packet capture would either. But it gives you a lot of interesting bits. So like I said, you see all the connections that took place. You get to see the timing, how many bytes went by. The digital certificate stuff is in there. Zeek is a great tool. It's open source. You can download it. Anybody can use it. So if it was, gee, I don't have this in place today, I need someplace to start, Zeek would be where I would start.
Great. Last question. Any good book you may want to suggest?
Not yet, but Strand and I have been talking about writing one. I've seen a lot of books that say they're threat hunting, but they kind of focus on what I refer to as kind of the minor attributes. Like the first thing that you should go in and do is look for unique user agents. And I talked about because everybody's got unique user agents. You always end up with some oddball system on there. An Atari 7800, an Amiga, whatever. Well, kidding. Atari 7800 did not have an IP stack on it, or at least not by default. But you get the idea. Everybody's got something unique. So to go looking for that first, not so much. The identify persistent connections. We're just starting to do that now. So I haven't really seen a good threat hunting book out there. Doesn't mean there isn't one, just means I haven't run across it yet.
All right, Chris, any final words?
No, that'd be it. Just like I said, we'll do the run book stuff next week. And part of next week, I'll also toss you a data set to go through and do a hunt on. And then the very last class will be, let's go through that last data set together to figure out what's there. That'll give you time to see, okay, Chris has been talking at me for weeks now. Has it actually set in, and has it actually helped me to be able to go in and find this stuff? So we'll be doing that over the next couple of weeks.
All right. Thanks for joining us today, everyone.
Hey, Jason, thank you for the help. Appreciate it.
Yep. Absolutely.
Thanks, folks. Later.